Hello and welcome to our lesson on rational numbers as exponents. This is going to be from section 6.2 in our text. Let's get started. First of all, remember the word rational in math usually refers to a fraction. So when we're talking about rational numbers as exponents, we're really talking about fractional powers, exponents that are fractions. And so we have a property that says if you have a variable to a fractional power, you can actually convert the rational exponent into a radical symbol. So that formula says that the denominator becomes the root and the numerator is the exponent. So this formula is a formula that you need to know, and it does go both ways. You can go from a radical symbol to a fractional power, or from a fractional power to a radical symbol based on what you need. And that's pretty much it for formulas. Let's jump into the examples. So our first problem says y to the 1/7, and the instructions say to write without rational exponents. So that's going to imply that they want you to write it as a radical expression. So if you have a rational exponent and you want to convert to a radical symbol, remember the denominator becomes the index. And just a way that I remember that, I ask my students, I say, where do roots grow? Well, roots grow underground. And so whatever's underground becomes the root or the index. And the variable is going to get raised to the first power. But remember, anything to the first power is itself. And so there is the expression written in radical form. Next, number 11, they want us to go the other direction. It says to write using a rational exponent. So here you need to remember that a radical symbol where you can't see the index, that means it's a square root with an index of 2. And so to convert that, that's going to become 17 to the, remember roots grow underground, so the root becomes the denominator, and the exponent, which here is understood to be 1, becomes the numerator. So we can say the square root of 17 is the same as 17 to the 1/2 power. Next example, number 20. Here the instructions want us to write the expression with a rational exponent. So the radicand is going to become our base. That's 2a to the 5th b. That does need to be in parentheses, because that entire base is going to be raised to our fractional power. The exponent is the numerator, the root is the denominator, and that's done. So these problems are not super difficult if you know where the pieces go. Next, number 25, the instructions say to rewrite with positive exponents and simplify. So what you need to notice here is that this expression is made up of two factors, the coefficient and the variable. They each have their own separate exponent. So the 3 has an understood 1 for a power. The x has the negative 1/4 for a power. Only the factor with the negative exponent is going to relocate. Now, what I mean by relocate, I mean we're going to take this expression and F it up. We're going to fraction it up. Negative exponents are not happy. They want to be positive. So if he is negative in the numerator, to make him happy, we're going to bring him to the denominator. But only the x comes down because only the x has a negative power. The 3 is happy. His exponent is positive, so he stays up top. The x comes to the bottom, and that makes his exponent positive. And now that all of the exponents are positive, we're going to say that that is in simplest form. Next example, number 35. Again, they want us to rewrite this expression with positive exponents and then simplify completely. Notice that this is one term with three factors. So each factor that has a negative power is going to want to move. So remember, the first thing we need to do is F it up. We're going to fraction it up, and that gives the 2 and the y somewhere to go. If they're negative in the top, they want to move to the bottom to be happy, and that means to be positive. So the x to the fourth is happy. He's got a positive exponent. He stays up top. 2 to the third in the denominator, y to the 2/7 in the denominator. And then we're going to say that that is in simplest form. Now that all of the exponents are positive and everybody's happy, we can stop. Our next example involves multiplication of variables with rational exponents. So if you watched the previous lesson on properties of exponents, you're going to know that when you multiply variables that match, what you do is you add their powers. However, in order to add fractions, you're going to need a common denominator or a calculator. And I prefer the calculator. And this gives us a reason to pull out the Casio. So we're going to use our fraction capability and let the Casio deal with getting a common denominator. So we have 2/3 plus 5/4, 23/12, and that is going to be in simplest form. And so we can say that this answer is going to be a to the 23/12. And that is it for that example. Our next example, number 53, here we have x to the 2/3 raised to the negative 3/7. So this is going to be another property of exponents that you need to know, that this is multiplication. An exponent raised to another exponent means that you multiply the powers, but to multiply fractions, you simply go straight across. And in this case, I notice that I do have a common factor top and bottom, so I'm going to simplify before I multiply. These 3's will cancel. And so that's going to give me x to the negative 2/7. Now that exponent is negative, and it's bad math etiquette to leave a negative power, so we're going to make it positive. That means we're going to F it up. We're going to fraction this expression up. And since the x is unhappy in the top, he wants to move to the bottom. Now that's going to leave nothing in the top, so that means there's still a 1 left in the top. And the x now has a positive 2/7. Also, what you could have done, instead of just moving the x to the bottom, is you could remember the actual formula for variables to a negative power. It says that you take the reciprocal. So flipping this over would make the exponent positive. Either way, we're going to get this answer as our final answer, and that is in simplest form. And for our last example in this lesson, number 73, the instructions say use rational exponents to simplify. So this is going to give us another chance to talk about how to convert from a radical symbol to a rational power. The fifth root is going to turn into an exponent of 1/5. The fifth root means to the 1/5. The square root means to the 1/2. Any radical symbol can be turned into a fractional power like this. And just recall that the root is going to be in the bottom. Now then, the radicand is the base, and I'm going to express 32 as 2 to the 5th power. because 2 times itself 5 times is 32, I can write that as 2 to the 5th. C to the 10th, D to the 15th. And then recall that if you have an expression raised to an exponent, that exponent will multiply to every exponent inside. So in other words, we're going to distribute the 1/5 to all the powers. And since that's an exponent raised to an exponent, that's going to be multiplication. So that's going to give us 2 to the 5 times a 5th, C to the 10 times a 5th, D to the 15 times a 5th. And then we can go through and do each one of these multiplications. Turns out to be super easy. Since 5 goes into 5 one time, that's going to leave us a 2. 5 goes into 10 two times, leaves us c squared. And 5 goes into 15 three times, leaves us d cubed. And now that expression is simplified completely using rational exponents. And that's going to do it for this lesson. So if you have any questions or comments about anything that I've done so far, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.